Hello everyone, welcome to my YouTube channel. Today we are going to talk about double linked list. If you haven't watched the video on single linked list, go back, watch it and come back later here. Without further delay, let's get started into the video. So what is double linked list? As I have said in the introduction video, double linked list will contain link to both previous and the next nodes. So for example, I have 4 nodes here. One contains the value 20 and the other contains 20, 30 and 40. These both are linked to each other. So the first one will be my head node, and this part of my every node is called previous, and this part of my every node will called next. For example, if I take the head node, the previous of head node will be null because head dot previous equals to null because there is no previous node. For example, the head dot next will be 20 because there is the next node and it is linked with 20. So 20 will be my head dot next. For example, if I am iterating over this linked list, if I have reached this position like 30, my current will be 30. Current equals to 30. If I wanted to delete, insert or do anything, I just have to remove the links, update the links. I have to update both the previous link and the next link. I have to update. If I wanted to delete this, I have to update the next of this node, and I also have to update the previous of this node. This is how double linked list will work. And there is, for the last node there will be no next because there is no next node. So the next of the last node will be null. So this is how double linked list will work. We will see the implementation part. Now I am going to the node file which I have yesterday. So in this file, what I am going to do is I am modifying this node according to the double linked list. So single linked list will only contain the next node, will not contain the previous node. It will not hold the link to the previous node. So what I will do now is I will just create one more node, previous, and there initially there is no previous node, so this dot previous will be null. Now we implement the double linked list class. In the double linked list class, first I have already created the doubly linked list class. So I will define this. Inside this we will have one method, one variable, that is head. I will copy the content from the single linked list class that I have created yesterday. The first operation that we are going to perform is insert at the end. So I will copy this method, and whatever the changes that are needed to implement double linked list class, I will make them. So what does this code does? It will first check if the linked list is empty. If the linked list is empty, we just have to make our new node as the head node. So we'll just do that. If that is not the case, we have to iterate until we reach the end of the linked list. Once we reach the end of the linked list, that means the current dot next is not equals to null. We will make current equals to current dot next. And if my current dot next is null, that means I reach the end of the linked list. Then I will make my current dot next as the new node. Now I have to check, I have to set the previous link because in double linked list we have both previous and next. So my new node will also have previous. Next will be automatically null because it is the last node. but I have to explicitly set the previous, because, so let's see, new node dot previous equals to my current node, because I am at the position, I'm making the next node as my new node. So this node will be the previous of my new node. So new node dot previous equals to current. Okay. We also want to display the content in our linked list. Whatever the data that we have in the linked list, we have to display that. So I will go to the single linked list class and I will copy this method. We don't have to make any changes to this because we are not modifying any content or any data that is already present in the linked list. We are just displaying the data. We are not modifying anything or making any changes to the linked list. So we don't have to make any changes to display method. Now I will test this code. I have already made it in the comments. Now I will just this one, and instead of single linked list we should have doubly linked list. Okay, now I will print this and display. Here I have created the object for my double linked list class. Previously I have object for the single linked list class. Now I have created list object for the double linked list class, and I am calling the methods in the doubly linked list class with this newly created list object. So I will go to the terminal. I will compile and now I will run the code. So see, all the data is inserted in the linked list. The next operation that we are going to perform is deleting by value. Deleting by value. It is also same as the single linked list. First we have to check if the node that we are deleting is our head node. If the node is the head node, then we will remove the link to the head node and we will make the next node as the head node. Okay, and we will set this previous as null. Okay, and then if this is not the case, then we have to iterate over the linked list until we found the key. We have to found the value. So whatever the value we wanted to delete, we have to search for that value. So we will iterate over the linked list until we found that value. That means we found that key. So for example, if I wanted to delete is 30, key is equals to 30, then what I will do, I will just iterate over this linked list. Once I found this 30, if my current equals to 30, then I have to make the previous of my current. If this is my current, the previous of my current, so I have to make this linked to this. So this should be linked here, not here. That means what is this? This is current dot previous. Current dot previous means current is this, current dot previous means this will contain the link to 20. So I have current dot previous means 20. I want this next. That means current dot previous dot next. Current dot previous dot next will be equal to current dot next. To have this previous, current dot next is this element. So I will just set current dot next to current dot previous dot next. Before doing this, we have to check one condition, that if my current dot previous should not be null. If my current dot previous is null, if I have only one node in the linked list, that is 30, and there is no previous and there is no next, then I can't set the previous and next of these nodes. So there must be some nodes, the previous and the next. Only we have to change the links only if there are some nodes previous and next. So I have to check my current dot previous is not null, and one more thing is we also have to check current dot next is not equals to null. Then we will do one more thing. If this is the case, then we will do current dot next dot previous. That means we are setting this link to current dot previous. Just the reverse of this. Now implement delete by value using double linked list. So I will go to the single linked list.java class and I will copy this method delete. I will paste it here and make whatever the changes that I have to do now. So what this code will do, first check if the node that we are going to delete is the head node. So if that is the head node, we will move to the next node. And also here we have to update the link of head. That means the previous of head. We have to check if the head is null. If the head is not equals to null, then only we have to update the previous. Head dot previous equals to null. You may get a doubt. We don't need node previous here because we have already designed it and defined it in the node class. So we don't need to have a variable again called previous. So you may get a doubt here that why we are checking head is not equals to null, because we already check current is not equals to null and the current will contain the head value. Here again we are updating the head equals to current dot next. If the current dot next is null, then our head will be null. So we have to check the head should not be null. If the head is not null, then we will update the previous of the head. And then if this is not the case, then what it might be, we have to iterate over the linked list and find the key. If we found the key, then we have to update. We don't need it here. We will just move to the next node. And if the current is null, that means if we reach the end of the linked list and we haven't found our key, that means then we will just return. And other cases that we have to check is, as I have said, if my current dot previous is not equals to null, then what I have to do, current dot previous dot next equals to current dot next. Okay. One more condition we have to check is, if current dot next is not equals to null, then we have to current dot next dot previous equals to current dot previous. Through these two conditions, we can update the links. Let's check if this works. Go to the main.java and see. We are deleting 30 here. So see, first we have 10, 20, 30, 40, 50 in our linked list. After deleting 30, we don't have 30 here. Try the other three operations by yourself. Delete by position, insert at beginning. I will include the code in the description. That's all for today. Thank you so much for watching. Have a good day.